Today we're going to learn how to multiply integers. Hello, I'm James Helfrich. Integer multiplication is built into every CPU, and this works great if we have a 1 byte, a 4 byte, or an 8 byte integer. What do we do, however, when we want to multiply numbers that have a different number of bits? Well, this video will demonstrate how to do that. To see how this works, we'll start with our own custom integer declaration. This one is going to allow us to specify any number of bits, not just 8 or 32 or 64. So it's going to be our pound include integer, and our full name of our class is custom on the custom namespace, capital I integer, because I can't use lowercase I int because that's a reserved keyword, 201. This is a 201-bit integer, which is enough for a 60 decimal digits. So I'm going to have the I left-hand side, I for integer right-hand side, and I for the product. And then I'm going to say I product equals I left-hand side times I right-hand side. Now additionally, I left-hand side and I right-hand side are going to be 0. That's funny. I forgot my semicolon there. Okay, so now I'll multiply these two together. I left-hand side and I right-hand side will both be 0. Therefore, I expect I product to be, well, 201 0 bits because I'm using a bit set for my underlying data structure. Okay, so now I want to do 6 times 7. I'm going to use 6 times 7 for a couple of reasons. First of all, because it's the answer to life, the universe, and everything. And second of all, it's because the binary representation is 0, 1, 0, 1, 0, 1. And sure enough, I do get 42 for my I product. But now what I really want to do is use a very large number of bits. To do that, I'm going to jump into Python, because Python has a big number class built in, and I'm going to specify two 30 decimal digit numbers. And when I multiply them together, I get a very big number. Now 30 decimal digits is about 100 bits. And so now I'm going to need a 200-bit number to do the product. So I'm going to take that number here and I'm going to put it into my I left-hand side and my I right-hand side. In order to do that, I need to have a string stream because I can't just assign an integer with that many bits because, like we said before, the C++'s integers are not that large. So I'm going to take a string stream that has that string I copied from Python. And now I'm going to use the extraction operator to put that 30 decimal digit number into I left-hand side and also into I right-hand side. So now I left-hand side and I right-hand side will both be 100-bit numbers. And then when I do the product, I want to be able to verify the result. Just the bits aren't going to really help me understand if the multiplication worked. So what I'm going to do is I'm going to create another string stream for the product. And then I'm going to use the insertion operator to take the result of that product and put it into a string stream. And now I'll be able to visually look at it. Now our implementation of integer is going to put 1,000 separators between the digits to make it a little bit easier to read. Now what I want to do is verify that this actually works. So I'm going to say, I'm going to have string stream verify, and then I'm going to go into Python and take that huge number that we did there and paste it into here. And hopefully these two things should be the same. Well, let's see if it's true. So I'll have bool same equals I product equals I verify. And hopefully same will be equals to true. Unless I made a mistake, of course. Let's see if I made a mistake. So I'm going to take I verify and I'm going to insertion operator that string stream into I product. Oop, it looks like I just made a mistake there, not to I product, but I verify. Okay, when I run this, let's take a look at what we got. Now, first of all, I'm going to go to I product, and that's going to be 200 bits. Notice how the 200th bit is set to 1, and then the 201st bit is set to 0, which is my signed bit. I verify is going to be basically the same thing, but I'm not really sure if they're the same, so I'm going to have to check them. So, but same equals true, and look at the streams. They're both the same, except S product is going to have the 1,000 separator. So it worked. Perfect. Binary multiplication works much like decimal multiplication. We will first demonstrate integer multiplication with decimals and then apply the same principles with binary integers. So I'll take for an example 26 base 10 times 19 base 10. So we have 26 times 19. So we're going to start with the 9, and 9 times 6 is 54. So the 4 gets carried down to one place and the 5 is carried. 9 times 2 is 18 plus 5 is 23. So therefore 9 times 26 is 234. From here we scoot over by one place and we say 1 times 6 is 6, and 1 times 2 is 2. Now that we've finished all the multiplication, we add them up, and 4, and then 9, and then 2 is 492. All right, we're going to do the same thing with binary numbers. We're going to start with 26, which is 000111010, and then we're going to take 19, which is 000010011, and we're going to multiply them. Okay, so first we'll start with the ones place, and 1 times 000111010 is just copy it down. And then 1, also copy down, but shift over by 1. And then 0, we just copy it down. Notice we don't have to carry it like we do with decimal multiplication. It's either going to be the number or it's going to be 0. Another 0, and then a 1, copy the number down. 0, 0, 0. And when I'm finished, I add them up all the bits, and that's going to be 00011101110. And so what's the pseudocode? Well, the product is the multiplier times the multiplicand. And so we'll have the multiplier and the multiplicand are the two parameters of my multiply function. So we're going to start with from right to left by walking through the multiplicands, and then we're going to take each one, and if that element is 0, I do nothing, and if it's 1, then I take that number, the multiplier, and add it onto the product. And then I shift everything over by 1 bit and continue, and shift over by 1 bit and continue. And when I'm finished, I have the product. So let's take a look at another example. We have 13 and 5, and we're going to multiply them using 8-bit binary. So 13 base 10 is 00001101, and then 5 is 00000101. So I'm going to multiply them together like before. And so remember, if the slot is 1, I just copy it down. If the slot is 0, I skip it. If the slot is 1, I copy it down. If the slot is 0, I skip it, skip it, skip it, skip it, skip it. And then when I'm finished, add them all up, and I get 01000001. Verify that 13 times 5 is 65. Okay, try this one on your own. We have 111 times 7. So first of all, convert 111 base 10 into 11-bit binary. Then take 7 and convert into 5-bit binary. Multiply them together, and that should give us a 14-bit number. And then verify that 11 times 7 is 777. Here's another problem to do on your own. Take 11 in decimal and take 12 in decimal. And first of all, convert them into binary. We'll use 9-bit binary in this case. So 11 decimal in binary, and then 12 decimal in binary. Multiply them together, and then verify that 11 times 12 is 132. You can learn more about how to multiply integers and work with integers in general in the integer chapter of the C++ data structures textbook.